All right, hi everyone. We are going to be solving the first example of chapter 5.2. The first example is question 85. So first, let me read the question. A keratometer is a device used to measure the curvature of the cornea of the eye. Light is reflected from the cornea, which act like a convex mirror, and the keratometer measures the magnification of the image. The smaller the magnification, the smaller the radius of curvature of the cornea. If the light source is 12 centimeters from the cornea and the image magnification is 0.032, what is the radius of curvature of the cornea? Well, first let's write down the relevant information. We are told that the mirror, the eye, act as a convex mirror. So that means, first let's write the number of the question 85. That means the focal length is smaller than 0. We are also told that the light is a distance of 12 centimeters away from the cornea, which means the light here acts as our object. So 12 centimeters, and I'm always converting to meter. Then we're told that the magnification is 0.032. So let's write that down also. M is equal to 0.032. Now remember that this value is also equal to minus the distance of the image divided by the distance of the object. We will need that later on. So the goal is, what is the radius of curvature of the cornea? So we know, as we've seen in the previous video, that the radius of curvature of a spherical mirror is equal to twice the focal length. In other words, if we can find the focal length, we can find the radius of curvature. So first, we will use the magnification equation to isolate the distance of the image. Since we already have the distance of the object, this will be used to plug into the formula that link the distance of the object to the distance of the image and the distance of the focal point. Okay, so let's start with the first step. We want to isolate a relationship between the distance of the object and the distance of the image. All right, so what we have here is that the distance of the image is equal to minus 0.032 times the distance of the object. If we take that value and plug it into the distance formula, if we take the distance of the image over here and plug it into that section over here, so we replace the distance of the image with that value, well, now we can isolate the value for the focal point. The focal point will be 0.00397 meter. It's roughly equal to 0.004 meter, or 4 millimeter if you prefer. Now, looking at this formula, the radius of curvature is simply twice the focal length. So radius of curvature is equal to 0.008 meter, or 8 millimeter. All right, so that's it for question 85. Let's go solve some more problem.